Hello class, this is a video to explain more about the week 5 exercise. The exercise 5 for week 5, actually exercise 4 is slightly different with other weeks. And then here I'm trying to walk through RStudio first and then Excel for Excel users in the class. The point is the Excel is slightly different with RStudio, so don't try to check your number in Excel with RStudio. So this is these are the questions. You should go with model 1, model 2, model 3, and that's it. 3 models for exercise 4. In the first model, the question asks, run a linear model and predict differences between hospital beds and hospital ownership and hospital net benefits. Actually, discuss your finding, and you think having higher bed has positive impact on the hospital net benefits, or what about the ownership? So, as stated here, the dependent variable here is a net benefit, and the independent variable is hospital bed and ownership, 2 variables, but the ownership divided in 3 different variables: for-profit, not-for-profit, and other. So let's go first to RStudio. This is the same data set you're already using for the other exercise. And then let's go first with okay, this code is in the class. There's 2 options to go with this. First, you can just go ahead and run everything and save the sync file, and then go through the sync file and populate your table. The other approach is go step by step. So let me go first with the sync command. So I just need to highlight, select all, and run the codes and see what was the error message here. I must, okay, that's fine. There's a problem. There's not a problem with actually Deepler package. It's fine. Let me go to the CUMUC and let's see what do I have there. CUMUC, and it should be here. That's it. Okay, this is a mean. Okay, this is the first model actually here. Benefit hospital beds on one is a factor variable 0, 1, 2, 3, and if you look at the code, there is a definition here for the ownership. 0 is for non-for-profit, 1 is for-profit, 2 for public, and 3 for other. If you tabulate this, you can see the distribution here: 0, 1, 2, 3, 4, 3, 4, and then the first set of codes generates actually the summarized table to see the distribution of your data. As I see in the class, we didn't ask you to complete that, so never mind. So you can just start directly with the regression model. The regression model started from here. I have line 101 in my computer, and then if I run this, I can see these results, right? This is a formula: benefit, hospital bed, ownership as a factor variable. And this is the formula that actually RStudio used for this. And you see here, you see the coefficient. The intercept is actually a constant. I don't know, let's see if the model asks you to report the intercept. No, so you don't need to report intercept as well. The intercept is a concept that it is always positive. There's always positive impact between the hospital bed and the hospital net benefit. So, and this positive in this is in the value of dollar. So for always positive. So I'm not gonna discuss more about this. And then if you go with hospital bed, I see with 1 unit increase in hospital bed, you expected to have $40,959 benefit. And if you look at the p-value here, the p-value is significant. 2 in e on power of minus 16 is very small number, is very almost close to 0, and we know if the number is less than 5% or 0.05, so there is a significant differences between there is a significant actually the impact is significant when we are just trying to talk about the regression model. We can go with 5%, 1%, 10%, as you see here. This is the symbol actually RStudio used to show the significant differences. And the significant difference with 3 asterisk, RStudio goes with 0, 1%. Less than, okay, it's very even less than it. This is 3 asterisks and goes with less than 10,000. I mean, not here. Let me explain like this. When we have a 5%, we expected any p-value less than 0.05. When we have in 1%, we have expected in p-value less than 0.001. And when we expected to have in 1000, the p-value is 0.0001. So this is the sign here. So it means really strongly significant. Even if it was 1 asterisk, it was significant. So you stay with 1, and then if you have even 1 asterisk here, you can say this is significant. If you go with look at the ownership and look at the ownership, the ownership is a non-for-profit 0, one-for-profit, public, and other. And as you know, the regression used the non-for-profit as a reference group, and those, so there is no coefficient for them, for the non-for-profit hospitals here. So it's a study with owner 1, 2, and 3. The 1 is for profit, 2 is for public, and 3 for other. If you look at the class, you have for-profit, non-for-profit, other, right? So the question asks you about the non-for-profit. For the non-for-profit, you should report that NA, non-applicable, because that's a reference group. This is a point you need to consider for that. And okay, you have hospital beds, you have a coefficient, you have a standard error. This is a standard error here. You have this one, right? You have the coefficient, you have a standard error here. For example, for the hospital bed, you should report 49,959, 1221 as the standard error. For the owner 1 is the owner 1, right? The owner 1 is for profit. You should report this value, these two value for coefficient, and for other you should report this. And also for sure there is no coefficient for non-for-profit. For n and r squared here, so to report n, you have this n here, right? You have a degree of freedom. The degree of freedom, as we stated in the previous ANOVA, it's a k minus 1, and k is a number of group minus 1. So here you have 3025, and for number of group you can count the variables. So you can see 225 plus 5, right? You have 1, 2, 3, 4 reported variable, and 1 variable actually is a reference group. So you have 5 variables here, 3025 plus degree of freedom here plus 1. This is the other way. So you can say 325 plus 4 plus 1. It actually should be k minus 1, right? So the k is here is 4, and it's a the 4 is a k minus 1, right? 5 minus 1, it was 4, and then you have 3025, so you basically have 30. This is the value, this is the end for you here. This is for model 1. And let's go to the model 2. The model 2 ask you to just, you know that here, right? Because this is coefficient scenario, and you can report the asterisk here as a p-value, or you can report a p-value here. If you like to report a p-value, this is a p-value. So you can either report the asterisk if there is, if not, we don't need to report that. Okay, the second model is here. The same model plus membership, right? There's one variable, extra variable here. Not extra, the new variable. The model 2, right? This is model 2. This is the, if you look at the code, I just try to look at it bed as a categorical variable. So this is extra information if you like to see the impact. Okay, here, the impact of bed category on this, you can run this model to see in which bed category there is a significant difference. Just for your information, you don't need to report the class. I'm going to the model 2. The model 2 is here. Benefit hospital bed ownership system member. And if you run this, I have hospital bed here, I explain here, ownership 1, 2, 3, and the system membership is here. If the hospital be in a network of providers, we expected to have 5.27 million dollar extra benefits, and this is significant. This is the message for the second model, and still hospital bed is significant. The ownership doesn't have, so there's no changes in ownership direction actually. Okay, let's go. Okay, this is, you have all of them here. You can report here ownership, non-for-profit, non-applicable, other, and system membership, and n should be n plus k plus 1, right? And n, oh, I didn't explain r square here. N plus, okay, do you have n here, right? 224 plus 5 plus 1, same number, 3030 observation. And the r square, this is a residual standard error, we call it, and this is a multiple r square adjusted r square. The r square is this number. I mean, the r square means that this model observe 5% of error, so it's not a very best fit model. But let's see, if you compare this this number 0.05, 52, 59 with the first model, and it was the first model, right? And we see obviously back then as category count this model. This is, yeah. If you compare this, r square is a 0.04861, and we have 0.05259. The second model is more valid model, probably, not probably, surely, because this model has a 1% more r square in comparison with the previous model. So this is the better fit model, model 2. And finally, I believe this is the final, right? Yes. Finally, we have the third model. And the third model here, the hospital bed ownership, membership, socioeconomic character, including the Medicare and Medicare. So we call them socioeconomic character. I can maybe consider this as a socioeconomic character, or yeah, any other number. So this is only this is a header, so make sure you don't need to report anything here. So this is header, so you just need to report the hospital bed. This is the ownership header, for-profit, non-for-profit, other. This is a header, system membership, social account. This is a header for this, and this is too. Okay, let's go with the last. Is it the last model? This one. the last model, this is the last model, and you see the hospital bed is still positive, even increased. The ownership is still negative, but none of them is significant. The system membership is not significant longer here if we include the Medicare and Medicare and ratio, and we see the Medicare discharge ratio has a negative impact on hospital benefits by almost 5 million, $5.1 million, and it is significant. And the Medicare discharge ratio still has a higher impact, maybe 3 times more than Medicare, and it is significant. So we can say, based on the last model, having a higher beds increase the benefits, being ownership being in a for-profit market, public markets, and other markets doesn't change. Actually, the market didn't change the benefits. That's very interesting. The system membership did not change the benefits in the full model, but Medicare and Medicaid has a really high impact on the hospital benefit, and both of them is negative. So more likely these hospitals are located, most of the hospitals are located in the region with higher Medicare or Medicaid patients. This is okay. If you look at the R square, is a 0.9064, and its comparison with the previous one is a 0.05259. Is it twice than that? So I can say this is the best fit model in comparison with all the model we reviewed. And okay, this is it for Excel. Even I expected to see some kind of plots, so for any reason we didn't report them here, so you don't need to report the plot, anything else, just coefficient. Now let's go with Excel users. The Excel has a difficulties to compute the binary variable. For that reason, for the Excel users, you just I changed this question slightly, and then you can go with model 1 and look at the hospital bed, the impact of hospital net benefit in teaching hospitals. And the second model, I like you to just go to the same model with non-teaching hospital. In the third model, I like you to include what's the model question? In the first one, in the teaching status, how it's impact, how adding the ratio, Medicare and Medicare ratio change the coefficient in teaching and non-teaching hospital. Basically, we have 4 different models. So the point is here, you do not need to report the teaching hospital here, because we are going to divide the data sets for teaching and non-teaching. So the point here is, for this model, you only need to report the hospital beds. Only, basically, this table should report only this one. Okay, let's see here. Excel user, right? This is here. You don't need to report this. Actually, this is no need. R square, you need to report R square, but you don't need to report this. I cannot delete here, but even the model one, so you just need to report these values here, these values only. And this for here, it should be this value only. Model 2, model 3 should be this value, and this 2. And for model 4 should be this value, and this 2. I will try to fix this in the class. For sure, you need to report R square. For the RStudio users, let me show in the first model. So you should report only this one. What happened to this? Okay, only this one, this 3, and I'm just going to make sure that it's non-applicable, right? You should report that. Okay, let's back to the Excel. For the Excel, this is the data set you have, right? So I did it here, but I'm explaining to you how to do that. First of all, copy entire data, right? Copy the entire data. If you used Excel for the previous week, so you know how to copy that. Actually, I hide this first, the line between the second line and line 3031. Copy here, and when you copy, just let me do it with you so we can do it how we want to do that. I'll copy here. I'm generating a new sheet here. Paste here. Okay, this is the entire data set. When you did that, go to the you need to see all the variable name here. Wrap it up. Where is that? It should be someplace here. You can see all of them, and you also need to generate the net benefit, right? Benefit, and this should be total revenue here minus total cost, this line. You should generate the interesting point about the running regression in Excel. It's you have to have all the variable in an order you like to run the regression. So the benefit is the dependent variable, and the second variable is hospital bed. So I need to copy the hospital beds from here, and I just need to copy here this and this. Okay, benefit, and then I need to generate the Medicare and Medicaid ratio, right? Let's look at the model. The model asks you to go with what happened to this. Okay, the model asks you to look at Medicare and then Medicaid. So let's go to this Medicare. It should be Medicare ratio, right? So let me call it ratio Medicare ratio, and the Medicare ratio should be total Medicare here divided by total hospital total Medicare discharge, total hospital discharge, yeah, total hospital Medicare discharge divided by total hospital discharge. Total hospital discharge is here, this one should divide by this. The same for Medicaid. Medicaid, it should divide the Medicaid, this is divided by total hospital discharge here. Then let's copy all of the codes to the entire of this page, entire data. You know how to do that, so I'm just trying to do it manually to show you how to do that. If you work with Excel the previous weeks, you should be able to do that now by yourself. Okay, these are all the variables you need: hospital, Medicare discharge, and Medicaid discharge. And then if you look at some of the variable here is actually non-applicable. This is the way you should go with this. You should filter the data, then click on the filter. Go scroll down to very down, I think to very end, and just select, first of all, select everything. Go to the very end, select this one, and change them with 0, otherwise you cannot get any result. Okay, so the same for here. Okay, then you can just unfilter this. This is fine. Select all and okay. Oh, this is the other point you need to go. The other point is you should go in the hospital teaching status, right? The hospital teaching is here. Where is that? Teaching status. Okay, is there any? I think this was not a system membership here. It was in the Excel file. There is no system membership. I don't see. Okay, you don't need to be worried about that. Let's back. You should sort your data based on the teaching hospital. So you can go to the very end, sort this line alphabetically, and click AZ or ZA. The first one is the teaching, one is for teaching, and you can expand the section sort. So if you scroll down, not page down, I think in line number 2000, here. Okay, here, line 2000, no, 900. This is teaching, right? Okay, you can also freeze this. I think you can freeze to see what's this. Freeze the top row. Then you can see what we are doing here. It was 930. Okay, it was here. So you can highlight this to make sure you will stay only with teaching, right? For the first model, you should go with the teaching. Never mind about that message, it was in my computer. And then to work with Excel easier, you can just hide the line between. So it should be here. You can just hide this lines. Hide this. This is non-teaching, right? Non-teaching. I don't need this one. Okay, and then you can hide the other part as well. Just keep the first and the last line. We have 3030 observation, and then you should see, okay, here. Okay, hide. If you are working with Excel for the first time, so these are the variables I need for the regression. If you are working with Excel for the first time for the regression, you should click on the file, go to the option, click on add in, add analysis tool pack. I already installed that. This should be here. If you are running for the first time, you should activate this analysis tool pack. Analysis tool pack by default is located here above this, and then you can click on go, and okay, you can click on go, and then you should activate that. Let me add one more just to show you how it's gonna be here, right? So, and you need to accept this. I will not do it because I already have. Then you should click on data, and you see the analysis here. First model, click on this. Let me go back. So first option here, add in, add the tool pack, and then click go, and then you see that menu pop up, and then you click on that, go to the data analysis, select the regression, okay, the regression, because I work with that, there is some observation here, but by default you don't have anything. So I'm clicking on this. One more point before I'm going here. Whenever you're generating the benefit, because some of them is negative, use absolute value here, ABS, and generate the benefit here. So use the absolute value, remove this one, so all of them is positive. So this is the point we need to consider. So let's go back to regression, click on data analysis, click on regression, and by default this page should be, this menu should be empty for you. You don't have anything in this, you will not see anything here. So I'm trying to click on this, and I can select the place I like to select for teaching, right? These are the teaching, this is a dependent variable. When you select them, click on this, it will show here. Then, or even let me go back here, let me click on data analysis, regression, I include even benefits. Let me click on this, I like to see here, right, and click on this, and then the other variables. For now I like to just include the hospital beds, it should be here, click on this, and then the question asks you to report the confidence interval, so you need to click on confidence level, you should click on the label, these are the label, and where do you like to see the output? I recommend you to put the output something placed like here. So something happened to this. Let's me back. Regression. Click on this. Select this part only. Come on, this part only. Then select this. Hospital only. Hospital bed. And then here label. Confidence interval activated, this one. Where do you like to see the output? My suggestion is to click here. Okay. And then you like to see the residual. I don't like to see. Do you like to see the line fitness plot? I don't like to see that. So then you can just click on this. And the problem said there was this may not be formula. But the problem is output range is here. I like to put output here, just here. That's it. Okay. And this is the result for the regression first model. You have number of observation. You have the interesting point is that the Excel for the two variable run the ANOVA test. So that's interesting because the ANOVA result is a coefficient when you have two variables. This is the intercept and this is the hospital beds. In teaching hospital, the hospital beds has negative impact on the hospital benefit. So this is minus 2000 or 23.03. And this is the standard error. So this is a coefficient, the standard error, and lower and upper. So if you like to report this lower and upper, you have this one. This is the first model, right? This is a teaching the first model, M1. I'm going to show you how to compute the second model. It's for non-teaching, right? For non-teaching, you just need to click data analysis. Before doing that, make sure to add a label here. Right? These are the label, you need these labels. So these are the label, and this is the hospital beds. Let me call it SP hospital beds. Okay. And this is the first model, right? The first model was teaching. The second model was for non-teaching regression model. And this is the place. This is here, right? I need to select this. And then I need to select this. And everything is the same. I'm repeating it. I like to, okay, no. The place is the same. I need to change the place. I like to copy here. And okay, this is for non-teaching, right? Make sure to put a note, non-teaching. The impact on non-teaching is, okay, it was teaching, it is non-teaching. Okay, this is non-teaching. Let me make sure we are on the same page. Non-teaching and teaching. Okay, the impact is positive. It is positive, right? 29.0, and this is a standard error. This is upper bound. This is upper bound. This is the lower bound. I think the question asks you to report this, and you have n here observation. You have R square here also. This is the first model, second model, the last model, the third model. Actually, I'd like you to include all of them. Click on the data here. Go to data analysis, regression. For the first model, I need to include this, right? This is the teaching. And this is second model. You should include all of them, right? All of them here. And I like to report the result here. This line, this, oh, I changed this. Come on, I changed. Let me go back. If you click any other place, it's going to be problematic. So go with this. The other way to check is you shoot the same number here. Let me go first. I don't. Okay, this should be this one. And the second one should be this one, right? Stay here. Label, confidence interval, and the place. The place I want to copy the result is should be here. This is here. And okay. What the model say? They say type of formula is equal. What is this? This place I like to copy here. That's it. They say the regression model include none. Okay, probably there is some place with some non-zero data, or maybe zero variables. Let's unfilter the data and see what the problem is. Unhit this one. If there is any place here, we should replace by 0. Any other place? Oh, I missed that in the first point over here. You can filter and do it, and then manually you can do it by filtering them. And I think that was, no, this is other place here. I believe I did everything. Okay, I think everything is okay. Yeah, one more. You should have a numeric value, otherwise you cannot do anything in Excel. And that was the message. And I have to do it one more time. Let me filter. Okay, if I filter that, it's gonna be here. I don't see anything here. That's interesting. Okay, let me go manually. Okay, that's it. I think that was the reason we couldn't do that. Let me go back and hide them. So not easy to work with a wide data like this. Okay, hopefully nothing is in the non-teaching. If it is, we try to fix that. I'm not going to do that now. I'll hide this. Okay, the third model should be like this. The third model is for teaching, right? Teaching full model 3. I'm going to data analysis, I'm going to do regression, I'm going to click on this, I'm gonna use this benefit. Okay, it's there. I'm going to use this, right? 937, and I like to see the place here. Okay, and okay, this is for non-teaching, teaching, and you can do the same for non-teaching, right? Non-teaching, non-teaching. You can click on dataset, regression, go with this, select this line, range from this, all of this, label active, confidence active, but the output, I like to put the output here, right? I like to put output here and here. So there's a no numeric data. Make sure to fix that. If you look at this, you can see some non-numeric data here. Okay, I'm gonna stay here and terminate this call, this video, so you can watch that and make sure everything's okay. Thank you, class.